Hey everybody, today's going to be kind of a quick video to show you a kind of a cool basic Dynamo script. To give credit, this script came about from the Parametric Camp YouTube channel, which I definitely recommend checking out. What I try to do is watch that because they talk a lot about Grasshopper, and I try to see if I can recreate those things in Dynamo. So here is the channel if you want to check it out. So you'll see it here, and I'll put it in the link below this specific video. But check it out. I love this channel. I've been following him for a while, and I try to watch the videos every day. I think he posts almost every single day, but I totally recommend checking this video out, or actually this entire channel. So with that said, what he was trying to do was lay out essentially park furniture or benches, and then parametrically flex them and rotate them, and then there's a point where he creates an entire grid of them and then rotates them. So pretty interesting stuff, and I won't dive too deep into all of that. I think he does a fantastic job explaining all the different nodes and connecting them and what you need to do. But I'll show you kind of in Dynamo what I did. So in here, I've got a bench family, and so this is kind of what it looks like. I haven't created families in a while, but this is just an extrusion here, and this is just a sweep, and that's the bench. And so with that family loaded, that's what we will kind of array across this polyline. So if we click on this, you'll see this is just a line. So if I do LI, all I did was I clicked LI on the keyboard shortcut, came up here to the spline, and then just drew kind of whatever shape. And then in Dynamo, what we're going to do is select on that. And before I show you that, you can see here that this is, if we kind of move this around, you can see it changes the diameter of, or the rotation of these benches. If I click on this spline, kind of drag that out, add other control points to it. That'll kind of move around. Something that I did, and which isn't mentioned in there, because he's kind of flexing the distance between them, the benches themselves, so the width and the length and height of them. We have a static bench here, and the idea that I was thinking was like, okay, maybe we could use this for kind of some type of design. Maybe it's plants or maybe it's benches, but in that case I don't want to try to figure out the distance between each of these benches. So something I added to the Dynamo script was I created a bounding box around the bench, and then I just figured out the if it was whatever the max number was, if it was the length or width, whatever that was, I ignored the z-axis. And I only grabbed the length and the width, not the height. And I figured out which one was greater, and then that's what I used to determine the distance between each of these points. So when we rotate these kind of around, like so, they won't be running into each other. So it's the distance, so it's the bounding box, and then +1. So that gives us, or let me check that. I think it's +2. Nope, it's +1. So it's the longest distance, and then +1, and then that allows us to kind of rotate this without those benches intersecting, especially since we're not flexing those benches. Now we definitely can. We can add the parameters into those to make them parametrically flex in all the different directions, and I think that's an awesome thing to add to this script. And I would definitely recommend if you want to download this script and try to do that yourself. And you'll find everything in the description below. Just feel free to check that out and download it. So that's kind of the script, or that's what it does. And so if I pull this over, you'll see that we start off by selecting the model element, which is going to be our spline. And this here is the rotation. So this is going to impact the rotations of our benches. So that plugs in over here to the right. We need to get the family that we're going to be using. So this one I just called Parametric Layout of Park Furniture. And then we get the family by name, and then we get the family type. And then this is where I talked about the bounding boxes. And so this is, I also did this because I'm trying to think of like the work, like maybe this could be an actual script that somebody uses. Well, in that case, I'm trying to think of the workflow that best applies to the group of people that would use this script, and they are not adapt to going into Dynamo and doing a bunch of different things. So in this case, what I did, rather than having parameters that would flex a bench and allow you to do a variety of other things, I grabbed the bounding box of the family, which then gave us, if we look at this bounding box, you can see it gives us the min-max point. It creates a box around the element, and from there I just created a cuboid. There might be a better way to go about this, but this was pretty this was quick, and it seemed to be a good route, but I would love to know different options or how you guys would handle this. So with the cuboid, we get the length and we get the width, and we're going to ignore the height because that's not too important. And then we're just going to over here get the cuboid width and the length, and then we're just going to list the max item. So we don't have to get too fancy with any of this, because for the most part this script should only, or actually for all parts, this script should only be using one family type. So it's not checking the widths of a variety of different things. So all we have to do is list the maximum item, and then here what we do is we take that max and we add 1 to it, just so that we have a so they're not like exactly touching one another, and this kind of gives a little bit of a gap to it. We could also change this value, and actually what we can do is put Y there. We'll add a slider, and then we'll change that so that we'll put that at max 10. We'll change the step to 1, close that, and then we'll plug that in here, and that will actually allow us to kind of flex the distance. So you can see there, when we grow that, it gets bigger. So let's move Dynamo over, and then you can kind of see that inside of Revit. So here it's at 10. Then you can see it's kind of getting closer. You can also see we're getting more benches as well. So that allows us to kind of parametrically flex that and kind of see what kind of cool patterns and things that we can get out of it. So back into the Dynamo script, if we scroll over, so this will give us the max, and then now we can flex that a little bit. This curve link and this range, all this is trying to figure out is the breakup of those points. So where does all that stuff go, or where those points are, the range of points, because these are then passed up to here, and then the curves passed into it, and these are the segment links. So you can see here's our 10 points. And then we count. So we count, and then that goes All of this is for the radius, or the degrees that we want to rotate everything. So there was a few things I had to kind of go about differently, because I couldn't find some of the native nodes, or couldn't find some nodes that are in Grasshopper that are, that aren't in Dynamo. I had some trouble figuring out kind of how to do some things. So what this is doing here is pretty close to what Grasshopper has to offer. I couldn't find a node for series, which I know he had used at some point, but you may see things like that where it's like, oh, I don't know where to do that, and so sometimes you may have to do use one node and then combine it with some other nodes, and maybe with like a code block. So keep that in mind if you're watching that and you're trying to recreate it in Dynamo. There's a variety of things that are in Grasshopper that Dynamo just doesn't have. I do think it's really fascinating though to see, like, oh, how can you recreate those things, because it creates interesting situations where you're trying to figure out how to do it in a different way, or how to do it in the same way but with different nodes because they're not available. So up here, when we create the segments, what we're going to do is just grab the points, or the X, Y, and Z points of each of the points along that curve out here. And that's what we're actually using to pass into this family instance by coordinate. And all we pass into that is a family type. So when we kind of determine that over here in this code block, that's what will be passed into this, and then create, and then placed within Revit. And then after those are placed into Revit, with our degrees down here coming out of this node, what we can do is pass that into this family instance dot set rotation, and that will actually rotate those families. And this script doesn't have any dependencies, so you don't have to worry about any of that when you download this. But again, you can find the script below in the description. Just check that out. There should be a OneDrive link. You can go there to download this script along with the family, and then you can go ahead and kind of play around with it. So again, I'll just kind of bring this over, and then I'll slide some of these, and you'll see the effect inside of Revit and kind of what's going on. If we want a bigger distance between each of those benches, we can scale up that slider for the element distance. And then if we want to change the rotation, if we want to change this, we can bring it over here to a different spline. So pretty cool stuff. I think this is really, really fun. I have a lot of fun watching these videos and trying to recreate it in Revit. So I definitely recommend checking them out. Hopefully this was helpful and fun for you. Check out the stuff below. If you like the video, like it. Feel free to share it, subscribe. But anyways, I will see you in the next video. Thanks for watching.